The notes for 5.6. Today we're going to be graphing and solving quadratic inequalities. I know that there's not a ton of space to write on here, so if you do need a separate sheet of paper, feel free to grab one. Also, I'm going to be kind of going quickly, so it's not a big video or a long video, but if you need more time to write something, pause it, write what you need to write, or rewind it and play it back again so that you know what you're looking for, okay? All right, first thing I want to talk about is the steps on how we're going to graph our quadratics. Okay, so the first thing we're going to do is graph our parabola using critical points. So let me zoom in real quick, and that gives you guys a chance to kind of write down the key highlights up here. Critical points mean points that you can identify using the equation without a calculator. Okay, so the first one's the vertex. We can find the vertex by first finding the x, that's negative b over 2a, and then plugging that x in to find the y. Second thing we can find is the y-intercept. If it's in standard form, that just means we find the constant on the end. So if it was like 2x squared plus 9x plus 4, that 4 without the x, that's my y-intercept. Another way to look at it is it's saying I plugged in 0 for all of my x's. Last thing we can find is our x-intercepts, which is our solutions. Remember, that's by setting it equal to 0 and then solving for x. We've talked about several different ways to do that. You could use quadratic formula, you could factor it, you could square root it. We are going to do those three on this page so that you kind of have a refreshed idea. Now the topic is inequalities, which means we're not just graphing the parabola, but we are doing solid or dashed when it comes to drawing our parabola, and then there will be shading involved. Okay, so for the solid and dashed, remember solid is if you have an equal to, dashed is if you do not. The shading is going to be all based on testing a point. So if I move over here, 0 is going to be the easiest point to test. Now, if that's on the boundary line, like if that's your vertex or it's on one of your a point on your parabola, then obviously it's not going to work. We'd have to pick a different one, but it's probably the easiest to test 90% of the time. Okay. All right, I'm going to find these one at a time, but I'm going to do both pieces or both equations at the same time. Okay. All right, so let's start with finding our vertex. Finding our vertex, we are going to take our equation in standard form. We're going to use negative b over 2a. So in this case, negative, my b is a 6. My a is a negative 1, so 2 and a negative 1. If I simplify negative 6 and negative 2, that's going to give me a positive 3. And then we can just plug that 3 in for all of the x's and see what we get. So if I move over to this pink part, I'm plugging in a 3 for the x, plugging in a 3 for the x, and then I simplify. You could type the whole thing in a calculator if you wanted to, or you can go piece by piece. 3 squared is 9, with a negative makes it negative 9, plus 6 times 3 is 18, plus 8. That's going to give us 9 and 8, 17. All right, so we have our x, that's this part. We have our y, that's this part. Let's go ahead and write our vertex down at the bottom here. So vertex is 3, 17. And if I was going to graph that, I would need to make sure I know what I'm counting by on my graph. So if I zoom in here, it looks like my graph is counting by 3. So like 1, 2, 3, 4, 5, 6, and so on. So 17 is going to be up here, 16, 17. The x's are just counting by 1, so my vertex is going to be right about here. I'm going to label it with a V so you know vertex. Okay? Remember, you can pause anytime you need to. Let's do the second problem same way. I'm finding my vertex. I need the x first, and I do that by using negative b over 2a. If I wrote this out in standard form, which it is, x squared minus no x's, that's a 0. So my b is a negative 0. My a is the number in front of x squared, that's just a 1, so 2 times 1. Well, it doesn't really matter because 0 divided by anything is 0. That's the x part. If I take that 0 and I plug it in, 0 squared minus 3 just gives me a negative 3. So this is my x, this is my y, and we're going to write our vertex. 0, negative 3, and then we're going to graph it. 0, negative 3. All of my pieces on here are counting by 1s, so it makes that really easy to find. Okay? Again, you can pause anytime you need to. If you miss something, go back and find it. Second thing we're going to need is my y-intercept. It's probably the second easiest to find. Whatever you do, you were taking a 0 for the x and you were looking for what the constant would be. I've highlighted it in orange for both of these problems. My y-intercept on the first problem is an 8. It's in standard form. My y-intercept on the second problem is a -3 because it's the constant. If it wasn't in standard form, you would just plug in 0 for all the x's and see what it gives you. Okay? All right, let's graph these 2 points. So remember, we're counting by 3's over here on the first graph. So 6, 7, 8. I'm going to label him as my y-intercept. And I'm going to do the same thing on the second graph, but I'm just going to color in over that dot and label him again as the y-intercept. Now, if the vertex and the y-intercept are the same, that doesn't help us a ton. But on problem 1, it actually gives us 2 points. Let me show you something. Don't write this down. I know my parabola is going to look something like this, right? And I know it's symmetrical, which means that if there is one y-intercept point, then I know that however far he is away on the other side, there's another one. So if I was to kind of boldly show you this, so 0 to 3 is where my vertex is, right? So if I go 3 on the other side, I should be able to find another y-intercept. And in this case, it would be at 6, 8. Okay, so I don't want you to write the 3's, but I do want you to put another dot. So you have one again at 0, 8, and one again over here at 6, 8. Okay. All right, last one, and this one takes the most time, obviously, is finding your solution. So finding out where you hit the x-axis. Factoring is the easiest, fastest, most convenient way, but it doesn't always work. So if it doesn't work, we have to find an alternative. On this first problem, if I was going to try to factor it, again, don't write this down, I just want to show you really quick. If I was going to try to take this, I would say, is there a GCF? Yes. I'm going to take that negative out from the x squared. That turns me into a -6x and a -8. Now, is there any way to add up to a -6 and multiply to make a -8? You're probably thinking -2 and a -4 would work, right? But 2 negatives here would make a +8, and that's not what we want. If only one of them can be negative, like a -2 plus 4 or a -4 plus 2, now we don't get the 6. So because this is not factorable, we had to use a different method. On this first problem, we are going to use quadratic formula. So I'm going to give you a second to pause the screen, copy that down, and then we'll talk. Perfect. On the second problem, we needed to use square roots. So I'm going to have you pause it, take a second, copy that down. Perfect. Okay. So once I got my equations solved out and I know what my x's are, we are very comfortable stopping at this line. Okay, that's what we did for the whole last part of Unit 5, right? But if I tell you to graph 3 square root 17, I don't think you're going to know where that is, right? So I'm going to show you in Desmos how you can find that out. So if I were to type in 3 plus the square root of 17, it's going to give me 7.1-ish. If I type in 3 minus square root 17, it's going to give me -1.1-ish. Obviously, the decimals are important, but when it comes to graphing, you don't know the difference between 0.1 and 0.12. Same thing when it comes to the square root one. If I square root 3, even though it's positive and negative, that means I have a positive 1.7 and a negative 1.7. Okay? So let's go back to our graph and put those 2 points on here. So if I look -1.1, that's an x-intercept. And then 7.1, that's another x-intercept. Okay. Oops, intercept. And now I'll be able to draw my parabola. Don't do it yet because we got one more thing to talk about. For my second one, we're going to graph it at 1.7 and a -1.7. Those are going to be my x-intercepts. Okay. All right, once you have all the points, here's your big decision. If I go back up to the top, I'm looking at the yellow information, solid or dashed. So I have to know, before I draw it, what it's supposed to look like. So on this first parabola, there is no equal to under here. So this guy is going to be a dash. On the second parabola, there is an equal to. So this guy is going to be a solid. All we're going to do is connect the dots. Make sure you have arrows on here. First one is facing down like an umbrella because it was negative. Second one is solid, and he is going to face up like a U. Make sure you have arrows on both sides. Remember, you can pause anytime you need to write stuff down. Okay? All right, the final portion of this is deciding where we shade on this inequality, either greater than or less than the parabola, so that we can get our solutions. Okay, here's how you do that. All we're going to do is take the point 0, 0. So that would be right here and right here, and we're going to plug it in. If it makes the equation or the inequality true, then I would shade where it is. So if this one comes out true, I would shade inside. If it comes out false, I would shade outside. Okay? Same thing on the other one. If it comes out true, I shade inside where 0, 0 is. If it's false, I shade outside. Okay? All right, let's do that real quick. So if I come up here and I take this equation, again, I take this equation, and I'm going to plug in 0 for the y, negative 0 squared plus 6 times 0 plus 8. We all know that this just goes away. So all I'm looking at is 0 greater than 8. No, that's not true. If that point doesn't work, then I don't want to shade where that is. If you wanted to take a highlighter, you could do that. If you want to scribble like I was showing a minute ago, that's fine. I'm going to kind of use a highlighter though and show you that we are shading all around the outside because the inside did not work. Okay. I'll pause it at the end. Let's get through the second one first. All right, so we're going to do the same thing here. I'm going to plug in 0, 0 to this equation. So a 0 for the y, greater than or equal, 0 squared minus 3. We know 0 squared goes away. Is 0 greater than or equal to a negative 3? Well, yeah, 0 is always going to be greater than a negative. So if 0, 0 works, then I want to include where that point is. 0, 0 is inside right here. So I would shade everywhere inside. Okay. If you need to pause for a second, go ahead and write that down. We're going to hit the last part, which is all about down here, finding my solutions algebraically. So that's this part. Okay. I want you to think for a second about only worrying about the x-axis. Okay, so I'm going to zoom in real close. If on my x-axis, I ask you who got shaded, you would say I shaded before that x-intercept, big space in the middle, and then I shaded after. So I'm going to write my interval notation to look like that. So I have two separate pieces with a union in the middle. Okay? Remember, negative infinity is on the left, positive infinity is on the right. We never do brackets when it comes to infinities. If you forgot the bracket rules over here, if they're equal to's, that's when we use brackets. That's a closed circle, closed line. If we do less thans, that's a parenthesis, that's an open circle, or in other words, that is a dashed graph. And then infinities are always my arrows, or they're always parentheses. All right, so let's go back one more time to that guy. All right, so if I say, well, where is the x-intercept where it stopped that I didn't include? Well, I have two of them. I have 3 minus the square root of 17, and then I pick it back up at the other x-intercept, which is 3 plus the square root of 17. Okay? So basically, I'm only worried about using my x-intercepts because that's going to give me my solutions algebraically. Okay. All right, let's go over to this one. And again, I'm only looking at the x-axis. So if I look on the x-axis and I say, what part's shaded? Well, it would only be from one x-intercept over to the other. I don't have two intervals, I just have one. On those intervals, I'm going to include both sides because this did have an equal to. I am including both of these. My two x-intercepts are that negative square root 3 and a positive square root 3. Make sure you use the square roots. We're not going to do the decimals because then we get into rounding. Okay. All right, if you missed anything on the top, go ahead and copy that now. We're going to go down to the bottom. Bottom should go a little quicker. Perfect. All right, on the bottom, both of these are going to factor, so we make our life just a little bit easier. Here's the deal. We're going to solve it. We're going to solve it. We're going to get our x. We're going to graph our solutions. Remember, there could be one or there could be two. We're going to check a point to see if it works, and that's going to determine our shading so that we can write our interval. Okay, let's do both factors first. First problem, in order to factor, I need it set equal to 0. Okay, it has to be an equal sign so we can factor it. I'm going to check, is there anything that adds up to a -3 that multiplies to a -10? Yes. We could do x plus 2 and then x minus 5, which means that my two solutions, remember we changed the signs, are -2 and a +5. Okay, that's our first step. Let's do the same thing on the second problem. This one, I'm going to make it equal 0 first. And then I look and I see that there's a 6 in front of the x squared. I make sure that it's not a GCF. And since it's not, I'm going to go ahead and do a swing. So I'm swinging the 6 over to the 3. 6 comes off of the front. And it turns that into a -18. All right, so anything that could multiply to make a -18, add up to a -7, well, that's going to be x plus 2 and an x minus 9. But this is not our factors. Remember that because we did a swing, we have to do a divide. So I'm going to divide that 6 back out. And I'm going to make sure I simplify first. All right, so this makes a 1/3. This makes a -3/2. That way when I write my factors back out, I know that I'm not swinging the 6's back. I'm going 3x plus 1 and 2x minus 3. Okay, those are my factors. It also helps in writing your solutions because we know that those pieces are going to be my answers. I just have to change the signs. So the 1/3 becomes negative, the 3/2 becomes positive. Okay. All right, if you need to pause that, write it down, that's fine. I'm going to go ahead and get my number line set up while you do that so that we can graph them. All right, open and closed circles are important again. Remember, if we have a less than or a greater than that does not have the line under it, that is where we worry about open or closed. Okay, so no line means they're open. I have an open circle at -2, open at 5. Problem 2 has an equal to, so I'm going to include those. That gives me a closed circle at -1/3 and then closed circle at 3/2. All right, we get lucky on both of these. 0 is in the middle, so I'm going to check my 0. And by check 0, I just mean plug it in and see if it's true. Okay, let's do that on this first problem. If I go 0 is less than 0 squared minus 3 times 0 minus 10. I plugged in a 0 for the x, and I plugged it in for all of my x's and y's. Again, all of this is just 0. So 0 is less than -10. No way, Jose. That does not work, which means that my graph, I do not want to shade in the middle. I want to shade on the outsides. So my graph would look like this. Shading to the right, shading to the left on the outsides. Now, we're not done. We're just talking about the shading right now. Let's try problem 2. If I plug in 0 for my y's and for my x's, we all know that this part's going to turn into a 0. So 0 is greater than or equal to -3. Yes. Since the 0 works, I include this one, but not these two. So my graph would look like this. Okay. If you need to pause anything, copy it down, go ahead. Otherwise, we are ready to write our answer. Here's what the answer looks like. We are going to write our intervals based on how many shading pieces we have. So on the first problem, I'm going to have 2 intervals. I put that union in the middle. The outsides are my -infinity and my +infinity. The insides, because they were open circles, that's why I'm using the parentheses. My left side stops on -2 and starts back on 5. When it comes to problem 2, my answer only has 1 interval. Because they're closed circles, I'm going to use my brackets. I start at -1/3 and I end at a +3/2. Okay. If you need to pause it, go ahead. We are done with the notes. You do not have to start the assignment until we get into class. You are welcome if you would like, but you are not expected to start the assignment until we get back into class.